All right, so we are going to use the online version of MultiSim for doing this lab exercise just because I don't have a Windows computer with MultiSim. So things are going to look a little different, but you're welcome to use this instead of using the actual MultiSim. I don't think there's any features in the Windows version of MultiSim that isn't online, so we'll see how this goes. All right, so number one is we're going to play some components, and I am going to work out exercise 5 for you, and that way you'll see some of the different components and some of the trickier ones to do. So number one, we're going to put a resistor down here, and we're going to rotate it. Uh-oh. I'm still learning this. This is my first circuit building. And no, I don't want to reload it. So I was trying to figure out a way to rotate things. And there's a button for it. So we're going to put a bunch of resistors down. We'll just go ahead and put them down. This is kind of a little more annoying than using the Windows version because I know all the shortcuts, so I can rotate things just with Control R. And luckily these are all 1K ohm. So we're going to have one, and then another one here. And we can actually copy it. That's nice. And let's copy this guy. And we have one here. And one more here. Okay, I think we have 1, 2, 3, 4, 5, 6, 7 resistors. Next thing we're going to do is we're going to grab some sources here. There's a DC voltage source here, and it looks like a little battery. In your circuit schematic in the lab manual, it will be a circle, but in MultiSim it looks like this. It's called DC power. So there's one of them here, and we're going to copy this one, and we're going to rotate it upside down, and pay attention to this. I'm going to put the other one right here, upside down, so the current's going in the opposite direction. All right, before I get to the dependent sources, actually, let's keep going. So the next thing we're going to do is we're going to have two dependent sources, and they're not listed on here, so you have to click more, and then you'll see a voltage controlled voltage source and a current controlled current source. So we want both of these. So we're going to put this guy somewhere over here, and then we'll grab the current controlled current source right here, and we'll stick that guy here. And I believe we have everything we need now. All right, so I'm going to rearrange stuff a little bit just so things are nicer. We'll connect some wires. That's going to go down there. Now, I'll get to this in a second. Oh, we need a ground as well. See, I almost forgot it. A lot of people forget the ground, so make sure you put the ground. I usually put the ground just in the bottom of the circuit somewhere. And so like, for example, there. We'll go ahead and connect this top. And it's going to go to the 6-volt source. And every time you connect a wire, you should see a little dot appear there. If you don't see a dot, the wires aren't connected. And sometimes that happens, and then you don't see the dot, and then you'll get the wrong value. So it's important to make sure that you get the right value. All right, next we'll connect some of these bottom wires together. Let's put this ground over here. So ground's connected, it formed a little dot. That's good. Connect this guy here. And this guy also. All right. So we got our 4 bottoms. Do we have our 4 bottoms connected? I think we're missing a resistor here. Let's see. So we've got this guy, this guy, this guy, this guy. No, that's correct. We'll keep on going with our connections. I'm just going to connect everything together, and then I'll show you how to connect these dependent sources together. My goodness. Connect that. A little wire spool here. We'll connect this current source up here. And I'll actually show you what the answer is to this one, so you can verify that you got the right thing. Line up. All right, I'm not sure what's going on there. Why don't we move this guy here? See if we can, nope. It's not what I wanted to do. There we go. Much neater. Redo this wire. Okay. I'm going to redo this wire as well so it's nice and lined up. Okay. This is looking a lot better. Move that guy down a little bit. So that guy's a 12-volt source. All the resistors in this case is 1K. You can click on a resistor and click on this little gear right here. And you'll see all the values for them, and you can change it right there. So it's really cool actually, because it's pretty easy to modify stuff with this circuit. Now this guy right here is actually a 6 volt, so we're going to change this here, change that to 6. All right, we'll look at this. So this is your current controlled current source, and the gain given by the schematic is 2, so we'll change that. For this guy, the gain is 2 as well, so we'll change that. Everything else is 1K. We got a 1K here. Move that a little bit out of the way. And let's see, 1K, 1K. All right, that looks good. We'll call this node VX. And you'll see it on the lab manual schematic. It's called VX. It's relative to this node here, so technically it's not VX relative to ground right here. We'll just call it VX for now to make things a little easier. And now it's saying that this source right here, according to your schematic, is twice the gain of VX. So we need to measure what VX is. So this is our little multimeter, if you will, that's going to measure the current. So we'll just run this up, connect this to VX. Okay. Now VX is the voltage across R1. So we're going to connect the negative side right here. And so now you can see the probes are connected to VX right here and to the bottom junction right here. All right. So we're going to do the same thing with the current. Now current is not like voltage. When you measure current, you measure what's going through some wire. So we're going to have to break our circuit. Whenever you're measuring current in this class, make sure that you break your circuit. It's probably one of the hardest things that students struggle with in here. And so what it's saying is the current going through this resistor here is going to be what this thing generates, but twice as much, because we set the gain to 2. So we're going to break the circuit right here, and then we're going to take this guy and run it in here. We're going to take that guy and run it in there. So now you can see the current's going to go in here through our little measurement device, which is going to tell this guy how much current to generate, and then it's going to go back through in here. So I hope that's clear to everybody. And you can see where these are crossed. There's no dot there, so it means they're not connected there. If they were connected there in this case, it would be bad. But sometimes you'll see like wires like this, and they'll cross over each other, but they wouldn't be connected in the center, and so that's a problem as well. And so finally, what we're trying to find is the current going through here. So what we need to do is set up some kind of a probe or something. We can set up a current probe to say, tell me what's going on here. So we got the current probe right there. Let's see, that should work. Let's move it right here. And so I'll show you how to do this with DC operating point as well. These little probes are really neat. All right, so we got our little probe right there. And we'll call that probe I0. If it'll let me name it. Name it right here, I0. It's measuring the amps. All right, so I think our circuit is complete. Let's see if this works. And as you can see, we're getting negative 48 milliamps going down here. So this circuit is actually working. And we can look at some of the other features in here. So the grapher is usually what shows you the output of whatever you're doing. And you'll see this pop up in the Windows version if you run your simulation. So you can see negative 48 here. Don't take a screenshot of the grapher in any of your exercises. This is text, so I want to see this in a summary table. And in the next video, or the next section of this video, we'll go over this. All right, and if you have any questions, just let me know.